Welcome to the fourth video. Let's quickly go to open board right away. Okay, in previous video, discussed evolvable axioms, and there I said if a mathematical structure is simple at first, very specialized, then it evolves and becomes more and more general. And then I said, let's assume that the core of this, core of flexible, evolvable structure. That is the core of evolvable structure. And I said the core is constructed based on evolvable axioms. The thing is that if that is an axiom, this is an expression, this is something, this is a mathematical expression, something. And this is evolved into something like this, and then it evolves into something like this. There should be some logic that connects all basically different versions of this axiom. So there should be this type of symmetry if you are familiar with physics and the notion of symmetry in physics. There should be a type of symmetry that actually organizes these axioms. But of course, the symmetry in physics is not available at this level of mathematics. So the question is that what type of logic can be used in this situation? I mean, conventional logic is that, for instance, expression A and, for instance, and expression B, or expression A or expression B, something like that. So you can expand, or if you like, evolve. I do call it evolve, but if you wish, you can evolve mathematical expressions by and or etc. But this is not useful here. This is not suitable for this purpose. Something should be, a new type of logic should be found for this situation. Let's consider this. Let's consider house of cards. House of cards. When you put a card, though I'm not going to draw it because it's difficult. I'm not even trying to. Okay, I'm not even trying to draw it. Uh, but you can imagine that. You can imagine follow that when you place cards on top of each other, it becomes more and more unstable. So basically, it when someone tries to say something and they reason, if they say nonsensical things, it becomes clear after a while because there are so much contradictions that things are not add up together, and there are lots of contradictions, and the more nonsensical things one says, the more unstable the overall expression becomes. So a type of logic is required that deals with stability of expressions. So instead of this and or expressions here that connects different mathematical expressions, something is required that deals with stability of mathematical expressions. I mean, if you like a mathematical paragraph, for instance, a mathematical expression here, a mathematical expression here, a mathematical expression here, and all of them construct a collection of mathematical expressions, and all of them together should be stable. I mean, you shouldn't be able to find a contradiction in them. So, you need a new type of logic that deals with that. That deals with finding a suitable, stable, structure for those mathematical structures. As I said, my previous example was a reasoning of someone saying something nonsensical. And when they say more nonsensical stuff, it becomes even more unstable because there are so many contradictions in their statements. So, okay, this is the first step. This is the second step. The first step was to discover what evolvable axiom actually are. Evolvable, evolvable axioms. But now the second, this was the first question. But now the new question is this new type of this new type of logic. So this is a new territory. We started with evolvable axioms. The new question is this type of logic that deals with nonsensical stuff, things that deals with stability of paragraphs of mathematical expressions, things like that. Okay, thank you very much. I think this is enough for this um, video. Thank you very much.